During the course of its 9-year mission in our relentless search for extraterrestrial life, we have already discovered over 5,500 exoplanets, dozens of which may have conditions suitable for life, and many other planets are so bizarre they capture your imagination. NASA continues to find new alien worlds almost every day. However, recently, scientists have discovered a very strange planet that might not only be habitable, but could have a form of life that turns our entire worldview about life upside down. Get ready to learn how astronomers found a planet that shouldn't exist. NASA's Kepler telescope focused on over 500,000 stars and revealed that 20 to 50% of all visible stars may harbor potentially habitable Earth-sized rocky planets. View a different celestial body that serves as a cosmic mirror and observe how a different planetary system executes an intriguing cosmic mathematical dance along with a ton of additional music. Studies have shown that red dwarfs have a higher chance of supporting life than stars like our Sun, and that there are more red dwarfs than any other type of star in the universe. In 2023, astronomers discovered an interesting exoplanet around the red dwarf star TOI 715, which is located in the constellation of Volans and is 136 light-years away from Earth. From an astronomical perspective, this is our celestial neighborhood, similar to a home nearby. The red dwarf star TOI 715 is orbited by the super-Earth planet TOI 715b. Among other requirements, an exoplanet must be either a rocky planet or a water world. By examining the exoplanet's parameters, scientists can predict its composition and determine whether it is a gaseous rocky planet or a watery planet. An exoplanet is considered a super-Earth if its mass exceeds that of Earth. For example, 715b is 3 times as massive as our planet and has a radius of about 1.5 times that of Earth. Rocky planets are typically those that have a mass of 2 to 10 Earth masses and a diameter that is between that of our planet and Neptune. However, the exoplanet is unique because it is situated precisely at the right distance from its star. TOI 715b receives enough heat to potentially have liquid water on its surface, and where there is water, there may be life. Red dwarfs like TOI 715 frequently have multiple worlds densely packed within their habitable zone. In our cosmic search for habitable worlds, astronomers speculate that there may be one more planet in the system that is just roughly 7% larger than Earth. If this theory is correct, it will be the smallest exoplanet that NASA's Transiting Exoplanet Survey satellite has yet found in the habitable zone. Despite our limited knowledge of this newly discovered exoplanet and its possible neighbors, planets like T715b seem to be our best bets. Imagine the excitement if future observations reveal an atmosphere and even liquid bodies on its surface similar to those we've previously spotted on Saturn's largest moon Titan. The possibilities are exciting. Maybe one day, our descendants will be traveling vast, uncharted landscapes and witnessing the unknown creatures roaming around this alien terrain. But for now, let's move on to other recently discovered exoplanets. The chances of discovering an inhospitable exoplanet are higher than those of finding habitable ones, even in theory. These planets pose many questions for the scientific community. One such celestial marvel is LTT 9779b, which is situated approximately 264 light-years away from Earth. What makes it so special is not just that it is the most reflective exoplanet that has ever been discovered. It is also a blazing hot world that is roughly 5 times wider than Earth and reflects about 80% of the light coming from its star, whereas Earth only reflects about 30% of sunlight. Cosmic Mirror is an abundance of reflective clouds of metal with titanium droplets raining down on its surface. The problem is, as scientists say, it's a planet that shouldn't exist. The side of the exoplanet that faces its host star is extremely hot, so hot that neither clouds of water nor even clouds of glass or metal should form in its atmosphere. According to our current understanding, a star located this close to an exoplanet should strip away its atmosphere completely. So what happened there? Researchers compared the phenomenon to condensation in a steamy bathroom. If you let the cool air and water vapor will condense, and if you let the hot water run, eventually the air will be so full of vapor, it wouldn't be able to hold anymore. Something similar could have happened on this ultra-hot Neptune when the planet's atmosphere was filled with silicate and metal vapor because of the scorching temperatures on its day side. But the exoplanet's uniqueness doesn't end here. Throughout decades of observations, we've detected a multitude of worlds orbiting their host stars in under one Earth day at a very close proximity, but all of them were either hot Jupiters 10 times wider than Earth or rocky planets over 2 times smaller in size than Earth. There was a population of missing planets, the sizes of which would fit between these categories. Scientists call this gap the Neptunian desert, until finally we've stumbled across LTD 9779b, which by its parameters fits right in the middle in a way. The exoplanet's reflectivity is its survival mechanism. If it absorbed much more heat from its star over time, the planet would slowly evaporate. LTT 9779b is a perfect target for follow-up observations by the Hubble and the James Webb Space Telescopes. Perhaps our technologies will reveal even more mysteries behind this already enigmatic celestial object in years to come. The planet we're about to discuss was discovered over a decade ago, but scientists have recently learned something about it that deserves the spot on our list. WASP-76b has 90% of Jupiter's mass, yet is just half as hot as our Sun and twice as wide. The planet's near orbit around its street star, which is only 3% of Earth's Sun's distance away, accounts for the intense heat. It is even the planet closest to the Sun, Mercury, is 10 times further away. Given that human bones, which are mostly made of calcium, vaporize at a temperature of about 1,500 degrees, and that one of the planet's sides is neatly locked to the yellow-white WASP, the location would be ideal for a cremation. Since the planet's discovery, researchers have studied the composition of the exoplanet and discovered 11 chemical elements in its atmosphere, some of which turned out to be rock-forming. At least that's what happens to them on terrestrial worlds like Earth. However, because of the scorching temperatures on WASP-76b, elements like magnesium and iron turn into gases that reside in the planet's upper atmosphere. Once strong winds carry these iron and magnesium vapors to the planet's night side, they cool and rain down as molten droplets of metal, making for a fascinating sight to witness. Additionally, astronomers have found a surprisingly higher concentration of nickel in the planet's atmosphere, which may indicate that in the past, WASP-76b swallowed a small, rocky world similar to Mercury that had an abundance of this element. Some planets in the universe differ greatly from our solar system, and WASP-76b isn't even the most extreme example. Recently, researchers discovered HD 110067, an amazing stellar system located only 100 light-years away. The system has 6 sub-Neptune's planets, each 2 to 3 times the size of Earth. Unlike our solar system, which is constantly changing, all of the exoplanets in the system are extraordinarily near their home star and have orbits that might fit between Mercury and the Sun. The structure of HD 110-67 seems to have endured for more than 1 billion years. The 6 planets are perfectly synced in a celestial dance known as resonance. The way these sub-Neptunes orbit resembles fractions in a mathematical equation. By the time the first planet completes 3 orbits, the second world revolves around its star twice. Each subsequent planet follows the rhythm, with the 4th sub, Neptune, for example, orbiting the star 4 times for every 3 orbits of the 5th planet, and so on. This discovery is exceptionally rare. Usually, young planets maintain these rhythms for a brief period until something goes wrong, like a passing star or more massive planets in the same system disrupting the balance due to their strong gravitational influence over 1,000 light-years away. In the constellation Pictor sits a binary star system, BOP1. That's where scientists have recently identified a new member, the exoplanet BOP1c, and it's not a typical planet as we know them. It belongs to the category called circumbinary planets, or such that orbit 2 stars instead of 1. They're quite scarce in our cosmic catalog, with only about 15 known so far, But there's more. It's the second circumbinary system that hosts more than one planet we've ever been able to detect. Interestingly, about 85% of stars in the universe aren't like the Sun. They usually have one or more stellar companions in the Milky Way alone. There are systems with clusters of 7 stars. Based on our current understanding, single stars only make up about 15% of all stars in the cosmos. The newly discovered world is approximately 65 times more massive than Earth, which makes it a gas giant like Jupiter or Saturn. In contrast to ordinary disks of matter surrounding a single star, in circumbinary systems, the planet-forming disks rotate around both stars, creating disturbances that make it difficult for planets to form. As a result, planets only have a chance to form in the calm corners away from the stellar chaos. Findings like these serve as a reminder of the endless celestial gems we're still about to uncover, even those that were once thought to be science fiction. Just imagine how breathtaking it would be to stand on its surface surrounded by a double sunrise. GJ9827d is the planet known since 2017, but just recently the Hubble Space Telescope has made an astonishing discovery about this world. The exoplanet is twice the size of Earth and about as hot as Venus. What you would never expect to find there is water, the key ingredient for life as we know it, but fingerprints of water molecules is exactly what the Hubble telescope revealed. Over 3 years of observations as the planet completed 11 transits 11 times when it crossed in front of its host star, the atmosphere of GJ9827b appears rich in water. And if the measurements are correct, this will be the first time scientists directly prove the existence of worlds with watery atmospheres around stars. Unlike ours, the planet may have formed in a frigid region farther from its star where low temperatures kept its water in the form of ice. Later, it migrated closer, slowly losing hydrogen due to its intense radiation, or it might have originated close to the hot star in the first place with traces of water already present in its atmosphere. Although even if that were true, this would still be a steamy hot world where life forms we're familiar with wouldn't be able to survive. The next step for scientists is to examine data gathered by the James Webb Space Telescope, which will hopefully provide more clarity about the nature of water-rich worlds beyond our solar system. As for the search for habitable world, a recent study suggests a new method to detect such planets based on the role of carbon monoxide in the atmosphere of exoplanets. When the production of carbon monoxide outruns its removal, something known as co-runaway, it can have an effect on the emergence of life on Earth-like worlds orbiting Sun-like stars in our Milky Way galaxy. There are potentially 40 billion such planets. By observing atmospheric dynamics of distant worlds, astronomers can focus on best candidates for habitable and even potentially inhabited exoplanets. What other celestial wonders await our discovery? Please let us know in the comments below whether you believe that any imaginary planet that has ever been imagined by humans has a real-world counterpart. Stay tuned for more fascinating space discoveries. While observing